All right, hey folks, I'm here with Ben Wood of Anakata Wind Power. Ben, very nice to meet you.
Nice to meet you, Adam.
And
How you doing?
I'm doing great. Mateo introduced us and appreciate that. And you have cool stories, and I'm going to bring up some of your props here.
Oh, go ahead.
Because we got to get right into it. What are we looking at?
So this is a tip booster, and it fits on the top of the blade tip, and we're boosting power, boosting AEP from the turbine. We're not increasing it above its rated power. We're just adding power in part load region. And this can produce, depending on the size and the model of turbine, it can produce between 2 and 6% extra instantaneous power. That might be equivalent to about 3 or 4% annual energy production.
Those are huge numbers, Ben.
Well, that's just one bit.
That's just one. Well, that's just this one upgrade.
Yeah, because Anakata's strategy is to come and put as much power on that turbine as it can usefully take, practically take, and within the margins of the life that's left on that turbine and the loads it can take. So we usually put on a tip booster, and then we put on some other plastic parts along the blade length, similar to some industry parts like vortex generators, but our background is from Formula One, it's from specialist aerodynamics, so we like to get some little leap in performance by bringing some of that technology onto wind turbine parts.
All right, I want to unpack it. You gave me a ton of info. So this one first, the tip booster, and this does separate. I think you did that before.
Yeah.
Is that quite literally what the installation in the field looks like?
Basically, it's like that. We prep the blade tip.
Okay.
There's a glue bond area that obviously when you're gluing something to a blade tip, there's lots of procedures that you need to make sure that's right. The sanding, the preparation, the conditions. And then, simple two-man crew can fit that within a day. And it's glued and then it's pinned with a metallic bolt system. And that also links into the lightning protection system of the turbine, which then feeds up to the top, and we've got a lightning.
And you put an extra puck there?
Yeah, right on the top there. So we continue the lightning protection system to the tip of the new blade, if you like, which is typically, 500 millimeters longer than the old blade.
Did you throw numbers out like 3 to 6 AEP? What did you say just for the tip booster?
Just for the tip booster, 2 to 6%.
2 to 6%.
So on some turbine models, for example, Siemens 2.393, this is quite a big tip booster.
Yeah.
And that'll give you 6% instantaneous power. And then on other blades, which are maybe longer and slenderer, or maybe are weaker in their design, an appropriate 2%, 3% power is what the practical engineering solution is.
Okay,
you
so
don't
if
want
it's
to
a blade
overstep
that's
the mark.
already pushed the load limits a little bit, it's going to stay a bit lower.
That's
What's
right.
the installation look like for something like that? How long does it take?
So generally, one tip booster could be put on in one day, in a sort of 8-hour day.
Tip a day.
Yeah. It needs a bit of painting at the end. There's a bit of touching up to do, but generally you are sanding the bonding area. You're drilling a hole for the lightning protection system bolt. You're making that electrical connection, which actually probably takes the longest time. That probably takes an hour, up to 2 hours in the process. And then the bonding process itself takes less than an hour. So it's about the preparation. Typically we see teams taking a day a tip booster. Sometimes when they start out, they're obviously a bit nervous about doing these kind of operations.
The learning curve.
Yeah.
The learning curve.
And we're quite explicit about what we want to see in terms of records of when they do this.
Yep.
This isn't a trivial thing to do to a wind turbine.
No.
And so we want to see photographic records, make sure that the adhesive's being applied in the right humidities and the right quantities. And so we have a very detailed sort of installation document and instructions for the guys. That does take a little bit of that time, but it's worth it because you have the assurance that it's been done right.
You need quality control.
Quality QA.
Definitely, when you're sticking things on blades.
For sure.
In general. All right, and you got more stuff you're sticking on blades.
Yep.
What's Up Renewables is growing, and we're looking for new sponsors to join us. Our show connects leaders, innovators, and field professionals across the renewable industry, and our sponsors are part of that conversation. Some have seen their network expand instantly. Others have grown revenue and brand visibility through the connections they've made right here. If you want your company to reach the people driving the future of clean energy, now's the time to get involved. Contact us at media@whatsuprenewables.com to become a sponsor today.
All right, and you've learned a lot of this through Formula One engineering group.
Yes, there's more money spent in one Formula One team than there is in all of these turbine blade manufacturers on true aerodynamic research and development. They spend millions and millions and millions of dollars, each team, every year, looking at improving the aerodynamic efficiency. So why not take those learnings and then try and improve something a little bit more worthy than the racing cars? I mean, I love the racing cars, but this is really cool because
This is
it's
more
like
worthy. I'm
race
with
for
you.
the planet stuff, you know?
Oh, there you go. That's
nice.
nice. Race for the planet. Little tagline here somewhere. All right, so what do we have on these VGs?
So these are two different types of VGs. These ones are some of our low drag VGs. So you can see they're slightly different to a normal triangle, which is what you'll find in the market. And what we're doing here is we are trying to increase the power of the VG a little bit, but we're trying to reduce the drag of the VG. That means we can put it further out on the blade, where the blade's turning faster. And the parasitic drag, which all vortex generators have parasitic drag. So minimizing them for the amount of those little vortices they make, the good stuff, is the game of making a good vortex generator. So we actually call them vortex entrainers because they are not just little triangles. They are actually a bit more developed than that. And then this one here, this is a higher lift version. So this goes down closer to the root of the blade. And you'll see there's discrete little steps in the top of this VG. And if you look at racing cars on the top side of their turning vanes, you'll find the same features.
Okay.
And that's because one single edge is going to shed one big vortex. Now that might look good, but it breaks down really quickly. So the work to re-energize the air and pull it back onto the blade fades as you go down the blade length. If you seed three smaller vortices, they'll wrap together around each other and they'll last for longer. And that sort of stuff comes from wind tunnel testing with PIV, which is a technique to looking at unsteady flows in wind tunnels, which is from Formula One. And so we're bringing those things in so we can make really more robust and stronger components. So these are pretty brutal VGs that will act and create very strong vortices.
Brutal VG.
Yeah. The other thing about VGs is where you put them on the blade.
Okay.
So the analysis techniques we've developed are quite different to the industry standard ones. And so where you put them and the size of them, if you like, that's just as key. In fact, that's more important than these features that we see here.
Interesting.
So this is more the extra 20% we get, but the real beer is in where you put them, how close to the leading edge and how far out on the blade, and the sizing of them. They're the key parameters to vortex generators in wind turbines. So we've also got some really good tech that will allow us to do that and really optimize everything we can get out of this little bit of plastic, which gives you power and everybody loves it.
That's amazing. All from Formula. Thank you, Formula One. All right, you got one more prop here. Let me get out for you.
Wow. Okay.
Yeah.
Okay, so this one's brand new. We launched this product last year. It's called the Vortex Slat. And you can see it's kind of like there's a little mini wing here that will create lift, piggybacking off the blade. But when we add several vortex slats together.
So I think it's like if I were to turn it this way,
That's right.
this is sort of the identical.
I should have brought two, because then you'd see.
Right, but what you've built is those two pieces,
Are
and
the
then
legs,
essentially
effectively.
covered it.
Yes, exactly.
Right.
Exactly. And then you scale this up a lot, because you're trying to capture really high energy air and push it back on the blade, get this working for lift, this part in the middle of the span. And then you're also having this, vortex generator type pairing effect.
Yeah.
And usually in aerodynamics, 1 + 1 = 1.7.
Okay.
But with this device, 1 + 1 = about 3. So we were really knocked out when we developed this in the wind tunnel, and then we've now got since last year we've been proving the robustness, the installation methods, the making sure the adhesion that we're using, the bonding strategies are all good, and so we've done. We did 9 turbines with it last year. Now we're going to do another 50 turbines this year. We think after a couple of years in service and inspection on...
That's with this piece?
Yep, how
Wow.
they're doing. So we really can start to shout about this now and start to bring a really brand new product into the industry. And I don't think anybody would argue they haven't seen anything like this before.
Never. I've been in nearly 3 decades myself. And however, you've taught me just some things about aerodynamics I haven't even heard of before. So that's clearly not my space. I understand conceptually, and then lived through these sort of iterations and upgrades over blades. I would say the oldest technology on wind that you have on your side is how to properly bond them. That's been happening. So you have that education from the industry, and then you're bringing aerodynamics engineering from Formula One over to wind turbine blades.
I think for us, because we come from our background, we brought lots of wind industry engineers in as well. We brought lots of QA engineers in. We brought lots of structures and adhesion engineers. Sounds like we've got so many engineers. There's about 20 of us, but
right.
We've all got that job to do. We started with specialist aerodynamics, and then we've adapted, learned, done our testing, got to a point that we have, I believe, the best assurance for fitting parts on blades, because yes, we want excellence in the aerodynamics, but we also want excellence in the speed of the install, in the assurance of the install, how long this thing is going to live, and then we can truly be market winners. If we just have one of those things, we can't.
No.
So and we've really worked hard and tried to make sure that the whole package gives you the best return on investment.
We'd like to thank our sponsor, Altair Energy Services, and their highly trained, expert technical staff, leveraging decades of renewable power management experience into customized solutions for everyone to meet their energy goals and contribute to a better future for all. Altair's team of hardworking, respected experts are providing full-scope, turnkey repairs, planned and unplanned maintenance, system upgrades, fully autonomous technical crews, supplemental staffing, and customized dynamic scheduling to fit your power production needs. Contact Altair at info@altairenergyservices.com and learn more about their wide range of capabilities across multiple power technologies and platforms.
All combined, you threw out an AEP number earlier. All combined, what are you guys estimating here?
So obviously AEP will depend on your wind profile.
Yeah.
So I know people bounce
Here's
around.
the engineer qualification answer. I like it.
But I'll throw some numbers. I'm not gonna disappoint you with it. So if we had like 60, 70 meter, maybe up to 80 meter turbine sizes, with all combined 8 to 10%, on your sort of 2 to 3 megawatt range, where you're sort of 90 to 100 meter rotor diameters, 5 to 6%, sometimes 7. When we get bigger than that, the sort of scale that we're doing things, we can't put a tip booster on relatively that big.
Okay.
and the blade lengths get longer, so the arrays take longer to get fit, so we tend to make them smaller. So we tend to come down to about 3 to 4% on the 150, 160 meter rotor diameters.
So still a lot more power.
Still a
You're
lot
starting with a larger
Yeah, absolutely.
source.
This is the thing, actually, your megawatt hours
Yeah.
is probably greater on those
It
big
could be,
machines.
right.
But the percentage doesn't sound as good, does it?
That's all right. Those percentage numbers got to be very attractive for wind turbine owners. Now, where are you seeing the largest interest from the customers? Is it when they're doing a repower, doing a repair, or is it, hey, I'm going to spend this money to go upgrade some of my turbines?
Well, up to this point, Anakata have been growing in Europe. So we've got specific clients that have quite large engineering diligence teams, and they want to put on as much power as they can. So really, they're into life extension and upgrade of their farm. Try and run it another 5 years. Try and run it with 5% more power. That's what ticks their boxes. Over there. We're learning about what the US market wants. We're doing our first project here with Aurora, who are our partners here in the US, and we are finding out that it works differently in that people want to order a product they know. So we had requests for, can I buy some vortex generators? But we kind of, yes, of course, here's a box of vortex. But what we really want to do is work with you, look at your blades, and say, this is a way we can get 5%, or we can't get 5% because of this, or actually your blades need repair. Don't think about upgrade yet. It's
Offer an engineered solution.
offer an engineering solution.
Yeah, that's the way to do it.
So that's what we're trying to do, but we'll adapt to the market, and our components are here for sale. Yeah, we're just really excited about our new venture in the US.
Well, congratulations, Ben, and thank you for coming and sharing with us. I look forward to hearing about you and Matteo and the first USA install happening pretty soon, and then updates from Anakata as your, design upgrades continue to age in Europe and fine-tune those AEP proofs. Those are amazing.
Yeah.
I mean, I would think customers would be really looking forward to
Check the
that kind of a
website.
bump. Yeah. All right. Thanks again, man.
Thank you, Adam. Nice to meet you.
You too.